Now we turn to what a doubly linked list really is. Let's look at the node first, and then two shapes of the list. Look at the picture. Each box is one node. It holds the data and it holds two pointers. The solid arrows follow next from one node to the node after it. The dashed teal arrows follow prev from one node back to the node before it. At both ends, the chain stops at null. Head and tail are our two handles. Head points to the first node and tail points to the last node. This is the caption for the two kinds of arrow. The solid arrows are the next links. The dashed teal arrows are the prev links. So head arrow prev is null and tail arrow next is null. Both ends are marked. This is the node in C. There is one integer field called data. There is a pointer called prev. It holds the address of the node before, or null at the head. And there is a pointer called next. It holds the address of the node after, or null at the tail. This is the same struct as chapter 4, plus one new field, prev. Now look at this ring. Suppose you want to cycle a list forever, like a scheduler or a playlist on repeat. We close the loop with two writes. First write. The last node's next now points to the first node. So tail arrow next becomes head. That links the ring forward. Second write. The first node's prev now points back to the last node. So head arrow prev becomes tail. Now there is no null anywhere. Walking next forever simply wraps back to the start. The key idea is simple. Nothing marks an end here because there is no end. There is no next equals null to stop at. So one handle is enough. We usually keep just a tail pointer because head is always tail arrow next. Circular doubly lists show up all over real systems. The Linux kernel builds its generic lists this way. That includes the list that links every running process.